Okay, we are going to work on question number 3, where it's from section 9.3 right here that I've circled. It says, hoping to lure more shoppers downtown, a city builds a new public parking garage. The city plans to pay for the structure through parking fees. During a 2-year period, a random sample, okay, so this is important, random sample of 44 days of daily fees were collected. The mean of this sample was 126 and the standard deviation was $15. A consultant predicted the daily average income would be $130. Okay, so let's look through the information that we were given. This should sound familiar because it's straight out of a problem from chapter 8. We've already found a confidence interval for this data, but I want us to run the hypothesis test for this. So let's read. It says a random sample of 44 days. So that means that our n value is 44. It's that key language random sample. And then we keep going. It says the mean of the sample. Okay, so the mean of the sample implies that this 126 is x bar equals 126 because that's the notation for the sample mean. And then it says that the standard deviation was $15. So we see that S is equal to 15. Then the last sentence, it says the consultant predicted the daily average income would be $130. Well, a prediction is a guess. So this $130 is important because it's our guess for mu0. Remember from our notes for the t-test, we need a numeric guess for the mean, and then we're going to decide whether or not it is greater, less than, or not equal to that guess. Okay, so part A just says for us to check the conditions. So if we're going to check the conditions first, the conditions for means are the same as the conditions that we had in chapter 8 when we were talking about confidence intervals for means. So the first condition is it a random sample? And the second condition was, is it nearly normal? So let's answer the first question. Is it a random sample? Well, it says up at the top that it is a random sample of 44 days. So we're going to write random sample of 44 days and check that off. Yes, that is true. It was a random sample. The second question is the data nearly normal? And here, since we're not given the original data, we are left to look at the n value. And so our n is 44. And if you remember from the notes from the confidence intervals for means, we need to check if this value is greater than 30. It is greater than 30. So here the central limit theorem does apply, and this data follows the normal model. Our conditions are met, so whatever results we achieve from this hypothesis test, we can generalize those results about the rest of the fees obtained for this particular parking structure. All right, let's look at part B to run the actual test. The question reads, would the consultant be correct at the 10% significance level? And then it says to write our hypotheses, perform our test, find our test statistic, so that's T, our p-value, and then state your conclusion. So here we're going to compare the p-value to our significance level, which I know everybody was wondering what that meant in the notes. So that means that that's the value that they provide for us here, that they refer to as the significance level. So they've told us that our significance level is 10%. That's been determined already. And so whatever our p-value is, we're going to compare it size-wise to 10% or 0.10. All right, let's go ahead and do step 1, which is writing our hypotheses. So step 1 requires an HO and an H1. And if you think of our notes, both of them have the same notation. Because this is a test on means, and we can see that based on the language in the paragraph, we're going to use the letter mu for both of our hypotheses. I did only give us one choice for the null hypothesis. I said it has to read equal to. And then we also want this to say it's equal to the guess. So what we're going to put here is the prediction by the consultant, $130. Now, H1 here is a little trickier than normal because I don't see any particular direction in the paragraph that says, I actually think it's larger, or I actually think it's smaller than $130. It actually just says, if we reread the question, would the consultant be correct? So this is a little bit tricky, but I'm either correct, that would be equal to, or I'm incorrect, and that would be not equal to. So what we want to do is test that the mean does not equal $130. So the null hypothesis says the consultant is correct. The alternative hypothesis here says the consultant is incorrect. The average does not, in fact, equal $130. Okay, let's go to step 2, where we go to our calculator. So here we're going to run a t-test, and we do have to choose how the data has been presented. But since we already read this little paragraph, we can see from the paragraph that they provided us with a mean and a standard deviation. Another red flag here is that there is no list of data. So this will be a t-test on stats, which means we will have to provide the calculator with the guess, the mean from the sample, the standard deviation from the sample sample size, and then the very last thing we're going to tell the calculator is that our our alternative hypothesis is not equal to. So let's find the values from the paragraph that we need to plug into the calculator. Then we'll pull up the calculator and we can make our conclusion together. Okay, so first we're going to go up to the paragraph. The guess was $130. That's the prediction for the mean value. The X bar is the sample mean, which we identified as 126 with a standard deviation of 15. And we said that came from the 44 random days that were selected. So what we want to do is go to our calculator. Here at the bottom, I'm going to write T equals so that we record our T-score. And then I'm going to set up over here so that I can compare my p-value to my significance level. So I know my significance level is 10%. I want to compare the p-value to that number size-wise as the very last step. So I'm setting up because I know that the output from the calculator is going to be a t and a p-value. I do know that there are 2 things I'm going to have to fill in. Okay, let's go to the calculator and run this first t-test. So in our calculator, we would hit stat, we would arrow to the word tests, and for once it's right here at the top of the page, we would hit option number 2, that's the t-test. Okay, so here you see that the choice is data. We actually need to move and select stats. Our first example here has stats, and you can see that everything underneath has changed. What we're going to do is input all of our information. Our guess was 130. Our sample mean was 126. Our standard deviation was 15. And our sample size was 44. And finally, when I go down to the bottom here, I want to click not equal to. Okay. This is the hypothesis we're going to use. If we ever have to select the others, we just would arrow to the right and enter. Okay. We're going to enter over top of not equal to and go down to the word calculate. So here we get our t-score, which is negative 7688 or 89, and our p-value, which is 0.08400. Okay, so what we want to do is try to make a conclusion based on this information. I'm going to pull the packet back up so that we can record that information. Okay. All right. 1 second. Okay, we're back. So what do we have from our calculator? Let's record all of it. Okay, let's record everything that we've got from our calculator. We've got t equals negative 1.76 0.08689 if we round it to 4 decimal places. And if we round our p-value, we have 0.08 oops, that's an eraser, 0.840. Okay, so at this point, it is time for us to make a conclusion comparing our p-value to our significance level for step 3. But before we do that, I'm just going to explain that t-score. It's a negative 1.7689 because our sample mean is in fact below the guess. That's why our t-score is negative. If our sample mean was above the guess, then what we would say is that t-score, would come out positive. Okay, let's make our conclusion. So I'm back over here looking at where I wrote the p-value versus the significance level. And I want to compare the size. I want to decide if that p-value is smaller or larger than the significance level. And so if we want to think about this as percentages as opposed to decimals, then the p-value is about 8% and the significance level is 10%. But the way I see it is that the p-value has a leading 0 in front of the first significant digit, and the significance level does not. So the p-value is in fact less than, oops, I didn't mean to erase, I'm sorry, y'all, is less than the significance level. Okay, this means we have to go back to our notes. Our notes said that if the p-value was small, this was in fact a good thing. And it meant we could reject the null. Okay, so if we reject the null, I want you to like go over to the right side or the left side of your paper and like literally cover up the null hypothesis. The null hypothesis says mu is equal to 130, and we just rejected that. That means that we do have evidence to show that the mean is different from $130. Our p-value is small enough to show that our alternative hypothesis is true. So there is evidence to show the mean fees differ from $130. I'm sorry, I have to squeeze that in the bottom corner there, but let me read that out to you one more time. There is evidence to show the mean fees differ from $130. So what we just showed were that the fees here are not equal to 130. Our p-value was small enough to say that H1 was in fact true. Okay, the next video will show question number 4. So I look forward to seeing you there.